Hello, everyone. So let's talk about the ECG. And I want to start with a pretty big statement. What if everything you've been trying to learn about ECGs is kind of wrong? What if all that painful memorization is just not necessary? Well, today we're going to show you that the ECG isn't some kind of magic. It's actually just simple, predictable physics.
All right, let's just get into it. Does this look familiar to you? I bet it does. For most of us, the first time we see a 12-lead ECG, it just looks like total chaos. You're sitting there thinking, okay, why on earth does this line go up here but then dive down over there? It feels completely random, almost nonsensical.
So what do we all do? We fall back on what we know, memorization. We just start chanting these rules, right? The P wave is positive in lead 2. The S wave is deep in V1. But here's the real problem with that, and it's a huge trap. Simply memorizing what happens leaves you completely powerless the second you see something that doesn't fit the pattern, because you have absolutely no idea why it's happening.
So today, we're going to stop memorizing. We're going to start understanding. And here's my promise to you. By the end of this quick explainer, you will never, ever look at a line going up or down on an ECG the same way again. You're going to see that it's not some crazy biological mystery, it's just a matter of direction.
Okay, so how are we going to pull this off? Well, and this is going to sound a little weird, but the real key to understanding the heart's electricity is to completely forget about the heart. Just for a minute. We need to strip away all the complexity and just focus on the one single fundamental principle that explains everything. So let's imagine we've got just one little piece of heart muscle, all by itself. We put 2 electrodes on it, one negative and one positive. Now this next part is absolutely crucial. When it comes to ECGs, the positive electrode is everything. It's our point of view. Think of it like a camera or an eyeball that's just watching. Its perspective is the only one that we care about. So what is this camera watching? It's watching a spark of electricity. And it happens in 3 simple steps. First, when our heart cells are just chilling out, at rest, they're negative on the inside. Step 2, stimulation. A signal comes along, channels fly open, and a whole flood of positive stuff like sodium and calcium rushes into the cell. We call that depolarization. And step 3, this first spark sets off a chain reaction, creating this moving wave of positive charge that spreads through the tissue. And that moving wave has a name, and it is the most important concept today. We call it a vector. So now we have our 2 key players. We've got our camera, that's the positive electrode, and we have our subject, that's the moving vector. With just those 2 things, we can lay out the rules of the game. These are the simple laws of physics that turn that moving electrical wave into the lines you see on the paper. And here is rule number 1. It's just beautifully simple. When that wave of positive charge, our vector, moves towards our positive electrode camera, the machine draws a line that goes up. I mean, think about it. Positive charge approaching a positive viewer. That's a positive event, right? So we get a positive deflection. And you've probably already guessed rule number 2. If that wave of positive charge moves away from our positive electrode, what happens? The machine draws a line that goes down. A positive vector is leaving our positive viewer. That's a negative event, so we get a negative deflection. It's really that straightforward.
So let's just lock this in, okay? The rules of the game are this simple. First, perspective. You always see the world from the positive electrode's point of view. It's your camera. Second, if a positive wave comes towards the camera, you get a positive upward line. Third, if a positive wave moves away from the camera, you get a negative downward line. And you might be wondering, what if it just passes by? Well, if the wave moves perpendicularly past our camera, the line just stays flat. We call that isoelectric.
Okay, I know, ions and vectors can still feel a little abstract. So I've got an analogy that I promise will make this stick in your head forever. Let's call it the paparazzi and the celebrity. Here are our players. The paparazzi, that's our positive electrode. He's standing still, he's our camera, and all he cares about is getting a great picture. The celebrity, that's our electrical vector, that moving wave of positive charge. And the celebrity is always on the move.
All right, scenario 1. The celebrity sees the paparazzi and runs straight towards him. This is perfect. The paparazzi gets a fantastic head-on shot. It's a totally positive outcome for him. And that perfectly shows our first rule. On the ECG, the line shoots up. Now, scenario 2. The celebrity spots the paparazzi, totally panics, and runs away. What does the paparazzi get? A useless picture of the back of the celebrity's head. It's a disappointing negative outcome. On our ECG, that translates to a line that goes straight down.
And finally, scenario 3. The celebrity just runs right past the paparazzi. Not really getting closer, not getting farther away, just moving across his view. The paparazzi is confused. Is this good? Is this bad? He can't really get a good shot. The result is just neutral. And on the ECG, the line stays flat. It's isoelectric.
So let's bring it all back home. By using these super simple physics rules, or just by remembering our paparazzi and celebrity, we can start to turn that chaotic mess we saw at the beginning into a clear, understandable story.
So here is the key insight. An ECG is not a bunch of random patterns you have to memorize. It's just a story about the direction of electricity, told from a few different camera angles. You do not need to learn hundreds of shapes. You just need to know where your camera, your positive electrode for that specific lead, is located, and then you just ask one simple question. Is that wave of electricity coming closer? Is it moving away? Or is it just passing by?
And just like that, you now have the fundamental tool you need to decode any line on any ECG. This isn't a trick. This is the actual language of the heart's electricity, and now you can speak it.
So where do we go from here? Well, in our next explainer, we're going to take these exact same rules and apply them to the real heart. We're going to place our camera in the right spot and finally understand, not just memorize, exactly why the P wave looks the way it does. You have the key. Next time, we're going to unlock that first door. So keep that paparazzi camera ready. We'll see you in the next explainer.